Hello folks, welcome back to Physics with Captain Rod. Purpose of this video is to demonstrate how to add vectors. So in the problem we're going to look at here, I've got two vectors here. Vector A is going to be 100 units long at 120 degrees of the positive x-axis. Vector B is going to be a length of 50 units long at 200 degrees with the positive x-axis. And we're going to look for the resultant vector, the resultant you get when we add vector A to vector B. All right. So first I'm going to talk about how to do the diagram. So I'm going to start by drawing vector A. Now, hopefully you can see this line that I have. Remember that angles are measured with respect to the positive x-axis with counterclockwise positive. So really this angle that I have drawn really would be like 0 degrees, and then this is like 25 degrees, 90. All right, 120 degrees is going to be, let's see, 90 plus, 30 more. So that's going to put us like right there. So I'm going to go ahead and draw vector A. Now I'm going to draw vector A. Actually, that should be long enough. I'm going to draw it that length. Now, one thing about vector A and the length, you can really draw the vector any length you want, but at this point now I've set a scale. So in my picture here, this length that I have drawn represents 100, and vector B is half the length of vector A. So when I draw vector B, I'm going to draw it at half the length of this vector. All right. Next, I'm going to draw vector B. Now, and a very important thing here is that I'm going to draw vector B starting at the tip of vector A. And again, I'm going to go back to the angles here. So angles measured with respect to the positive x-axis, this will be 0, and vector B is at 200 degrees, right? So 90, 180 is about there, and 20 more. So that's going to put us, I believe, right about there. So I'm going to draw vector B now, and I'm going to draw it half the length of vector A. So I'm just going to eyeball this. I think that's close enough. It's not important in this problem that I draw it so accurately that that the length is perfectly proportional, but I tried to make vector B roughly half of the length of vector A. Now, the resultant vector is the vector that starts at the origin here and ends up at the end of vector B. So our resultant vector looks something like this. Right. Our resultant vector has an x component, which I can, by the picture I can observe and see that that's negative, and it has a y component, which I can see that's positive. And those are what we have to find. That's what we want to try to find. I'm going to go ahead and do the addition up here. We want to find Rx and Ry. And here's how we find those. We go back and we look at the first two vectors. Now, for right now, you just have to just tunnel vision here on this vector right here, vector A. Right? Ignore everything else except vector A. I can draw vector A in component form. It has an x component and a y component. And one way to draw those would be like this. I'm going to go ahead and use my little ruler tool. Right, there is the y component, and oops, looks like this had to go up a little higher here. The x component would look like this. If I were to give these vectors names, I would call this one AY and this one AX, because again, the hypotenuse here is vector A. Now remember that A was at 120 degrees, and remember that this would be 90, and then that's 120. That makes this little guy 30 degrees. The trick here now is, again, kind of tunnel visioning on this triangle now, and ignoring everything except that triangle. The hypotenuse is A. The side AY is adjacent to the 30-degree angle, so I can find it using the cosine function. I'll go ahead and write it down here. The cosine of 30 degrees is equal to AY over A. So AY is equal to A times the cosine of 30 degrees. And A is equal to 100. So this is going to be 100 cosine 30. I'm going to go ahead and move on and find AY or AX now. Now notice that AX is opposite the 30-degree angle, so we can find that using the sine function. I'll go ahead and write this over here. The sine of 30 degrees, right? Sine, remember, is opposite over hypotenuse. So opposite the 30 degrees is the angle A. I'm sorry, is AX, and then the hypotenuse is A. So AX is equal to A times the sine of 30 degrees. All right, so I'm just going to kind of store these now, and I'm going to consider vector B now. All right, so vector B can be drawn in component form as well. So vector B goes basically that far to the left, and oops, there we go, good enough. Boom, there's the y component. So I would call this one bx and this one by. Now, remember B was at an angle of 200 degrees. So just a little reminder about what that meant. So this would be 0 degrees, 90, 180, and B is 20 more than that. So what we're finding is that this angle right here, whoops, I'm going to do that in black, that angle is 20 degrees. All right, this will allow us to find BX and BY. Oh, forgot my arrowhead on BY there. All right, you'll notice that BX is adjacent to the 20 degrees. Therefore, we can write this out. Cosine of 20 degrees is equal to bx, right, over the hypotenuse, which is vector b. Right, so bx is equal to b times the cosine of 20 degrees. And again, b is the magnitude of that vector, which would be 50. Right. by is opposite the 20 degree angle. So I'm going to go ahead and write out that sine of 20 degrees is equal to by over b. Right, so by is equal to b sine 20. Right, so just hold on one moment. I need to pause this just a second. All right, sorry about that. Had to just answer the door quick. All right, so what we're doing here is we're taking each vector, vector A and vector B. We break each down into horizontal and vertical components, or x and y components, and there's the y component of vector A, x component of vector A, x component of vector B, y component of vector B. And then what we need to do is find those components using right angle trigonometry. And again, the trick is you have to be able to just kind of focus on one thing at a time. In this picture, you focus on that triangle to find AX, AY, and you focus on that triangle to find BX and BY. Right? You find them. I haven't actually gotten numbers quite yet, but keep in mind that A is a known value here. It's 100 units, and B is a known value. Right? It's 50 units. So we effectively now we have, right, AX, and we have AY, and we have BX right here and BY. Right, now what we're going to do is we're just going to use those to find RX and RY. And I'm going to go ahead and just put in numerical values when we do this now. So Rx is going to equal the sum of these two, anything that's left and right. So that's going to be that one and that one. And although I say sum, it's a vector sum, so direction has to be taken into account. So Rx is going to equal minus AX and then minus BX. And AX is A sine 30, so this is going to be equal to minus 100 sine 30. Right, that's the length of that vector right there. All right, then we're going to have minus, all right, bx, and I'm looking here for bx. Keep in mind that b has a length of 50, so that's going to be minus 50 cosine 20. All right, to find ry now, we're going to be adding these, ay and by. And again, I say add, but it's a vector addition, so we have to take direction into account. So we're going to plus ay, and ay, I'm going to get right from here, is positive 100 cosine 30. And then I'm going to look over here. Here's by pointing down. by is equal to b sine 20. And remember, b has a magnitude of 50, so this is 50 sine 20. And it's down, so minus 50 sine 20. Okay. If we go through and calculate numerical values for these, I get negative 97 for Rx and positive 70 for Ry. All right. Now the $1,000,000 question, what do we do with those? Right, so what we can do now is we can use those to sketch the resultant. Our resultant, remember now, it's 97 to the left and 70 up. So I'm going to go ahead and draw a quick sketch, and I'm going to note that I'm not going to do it quite to scale because I'm running out of room. So I'm going to let this equal my 70 to the left. Or I'm sorry, not 70, 97 to the left. Oops. Get rid of that. So that's going to be 97 to the left, right, coming from this, and then 70 up. I'll just make that a little bit shorter. So the resultant vector is looking something like this. Again, not to scale. I've changed the scale up a bit. Here's an angle, I'm just going to call that theta. We can find the magnitude of the resultant by Pythagorean theorem. R squared is going to equal 97 squared plus 70 squared. And I'll take a moment here and calculate that resultant. 97 squared plus 70, whoops, 97 squared plus 70 squared, and then square rooted. I got about 120 out of that, so R, the magnitude of our resultant, is approximately 120. And then this angle theta we can find by using the tangent function. I'll go ahead and write this over here. The tangent of the angle theta is going to equal 70 over 97. So theta is going to be the inverse tangent of 70 over 97. I'm going to go ahead and calculate that. Right, what do I get out of that? I get about 35.8 degrees. All right, so here's our answer. When we add these two vectors up, our resultant is about 120. And I'm not sure what that little thing is. Let me get rid of that. It's about 120 units. And it's at an angle of about 35.8 from the negative x-axis. And if we wanted to, we could also give an angle with respect to the positive x-axis, and that would be 180 minus 35.8. So we could also say that the resultant vector r, that our resultant vector r is 120 units long at an angle of 144.2 degrees with the positive x-axis, I'll just put. Or, you know, another good thing to do is just draw a picture. There's the positive x-axis. Our resultant is like that. And there's the 144 degrees. Right? Any of these are sufficient for giving your resultant vector. Right? So going over it again real quick, trying to add the two vectors, 100 units at 120 degrees, 50 units at 200 degrees. The first important thing is that we be able to draw them. Right? Here's our first vector. Then, drawing the second vector starting at the tip of the first vector, we draw vector B. 120 degrees would be that angle right, or I'm sorry, 200 degrees would be that angle right there. Resultant always starts where we start, ends at our endpoint. Remember in your picture that you always add vectors tip to tail. Next, each vector needs to be broken down into x and y components. This is kind of nice. I went ahead and put my components in red. Now, here I chose to go like up and left, but I could have went left and up as well. Here I went left and down, but I could have also went down and left as well. You do whatever you think looks best on your picture. Next, find an interior angle in your right triangle and use right angle trig to find these components. And then when we add them, we just add our components. So that's a really important part of this problem, that when we add x components, these are what we're adding right here. And again, I say add, but it's a vector addition. Direction has to be taken into account. Both of those vectors point left. So over in the equation here, that's how we got minus and minus. And then when we do the vertical components, or the y components, we're adding this one and this one. And again, I say add, but it's a vector addition. And since this guy points down, that's why that minus sign is right there. So hope this video helped demonstrate how to add vectors together. Have a great day.